Okay, it's April 13th. We're going to look at the quick little quiz question we had. In the question, it was asked if you had a electron of some unknown atom thing you just found at a orbital energy of n1, it has an energy of e1 at this position. Okay. If we then move it to n equals 2, and E2 is equal to 1/4 of E1, then does this obey Bohr's model of the atom? And the short answer to that is yes, indeed it does. If you look at the derivation that was done in the Khan Academy video, we end up seeing in the end that the energy level, or the amount of energy at some energy level n, some orbital level, is equal to 2, and then there's some giant constant here. It's negative 2.17 times 10 to the negative 18th. And then this is over n squared. This constant here, that's like super annoying to remember in SI units. We will later on just remember this as negative 13.6 electron volts over n squared. So that constant is a lot easier when we turn it into EVs. But the real thing to recognize here is the n squared. Whenever you go up in a orbital level from 1 to 2, your energy change isn't dropping or changing by a factor of 2. It's changing by a factor of 2 squared, which is a factor of 4 in this case, which is what we have here. So yes, our made-up found atom thing, whatever we had in the problem, does obey Bohr's model here. Based off of this over n squared. So that's an important thing to recognize there. If we went to like n equals 3, then E3 would equal whatever E1 was over 9, because 3 squared is 9 and 2 squared is 4. So that's a quick little rundown of how we look at that. Hopefully it wasn't bad there. We'll be looking at this 13.6 EV over n squared a whole lot more as we kind of go through things.